Scientists all over the world, while studying the nature of individual atoms, needed high voltages to accelerate the charged particles, which could disintegrate the atomic nuclei. An American physicist working as a professor at MIT, Dr. Robert J. van der Graaff, designed and constructed a machine in 1929 to produce high voltages. As a mark of respect to its inventor, this machine was named as Van der Graaff generator. The principle of this machine is as follows. Let us presume that charge Q resides on an isolated conducting shell having radius r. There is another conducting sphere having charge Q and radius equal to r at the center of the aforementioned spherical shell. The electric potential on spherical shell of radius r is equal to Vr is equal to kq upon r plus kq upon r. The electric potential on the surface sphere of radius small r is Vr is equal to kq upon r plus kq upon r. Therefore, the potential difference between the surfaces of the two spheres is V small r minus V big R is equal to kq upon r plus kq upon r minus kq upon r minus kq upon r is equal to kq times 1 upon r minus 1 upon r. The equation above shows that the smaller sphere is at a higher electrical potential compared to the larger spherical shell. If the smaller sphere is brought in contact with the larger spherical shell, the electric charge will then flow from the smaller sphere towards the larger spherical shell. So, if the charge can be continuously transferred to the smaller sphere in some way, it will keep getting accumulated on the larger shell, thereby increasing its electric potential to a very high value. Van der Graaff employed the above principle and generated several million volts of electric potential. Such a generator is known as Van der Graaff generator. A non-conducting belt moves across two pulleys using a motor. One of the pulleys is on ground and the other one is at the center of the spherical shell. Charge is sprayed on the belt closer to the lower pulley using a discharge tube and a brush with sharp edges. The electric charge goes to the upper pulley using the belt, and with the help of another brush, it is deposited on the outer shell. In this way, a large amount of charge is accumulated on the largest sphere. About 6 to 8 million volts of potential difference can be generated. To summarize, we have learnt that the potential difference across Van der Graaff generator is given by Vr minus Vr is equal to kq times 1 by r minus 1 by r, where Vr minus Vr is the potential difference between the surfaces of the two spheres, k is a constant, Q is the charge on conducting sphere, small r is the radius of the conducting sphere, and capital R is the radius of the spherical shell. The electric charge will flow from the smaller sphere to the larger spherical shell, and it will get accumulated on the larger shell with the help of pulley and belt. That electric potential throughout the surface of a charged shell has a constant value. This property is very well utilized in a spherical capacitor. Stay tuned to learn about it.